a circuit using a double solenoid directional valve is said to have pneumatic memory. Okay, what is pneumatic memory? Pneumatic memory means that it has good memory. It can remember its last position. Okay, so let's take a look at this example over here. For instance, to make the cylinder extend, I will energize the first solenoid momentarily. Okay, in layman terms, it means that you give it power for maybe 2 seconds. Okay, the moment you do that, it will activate this box and it will stay there. Okay, so the air will just go into the ball end of the cylinder to make this cylinder extend. So you can see that the moment you energize this first solenoid momentarily, it will just stay there extended. Okay, so how do I make this cylinder retract? In order to make this cylinder retract, all you need to do is to apply the same concept by energizing the second solenoid momentarily, so that you activate this box over here and it will make the cylinder retract, as you can trace the air flow path here. Okay, so the key word here is momentarily, and it means that you just need to give it a pulse signal, meaning in layman terms, as I emphasize again, it means that you just need to power on for maybe 2 seconds on the respective solenoid to make it extend or retract. Okay, so pneumatic memory means that you can remember its last position, and double solenoid directional control valve is said to have pneumatic memory.
Now we are at section 4, circuits with double solenoid valve. Earlier we learned that double solenoid valve have pneumatic memory, which means that we remember its last position. Hence, you only need to energize the solenoid for double solenoid control valve momentarily. Okay, let's take a look at this pneumatic drive circuit over here. This is a single acting cylinder, this is a double acting cylinder. Both are using a 5-2-way normally open directional control valve. So let's take a look at this circuit over here first. As you can see, a single acting cylinder only has one air port. Hence, I will need a stopper at this 5-2-way normally open directional control valve, or else the air will be gushing out from the DCV. However, for this double acting cylinder, I do not need any stopper because double acting cylinder already has 2 air ports and they can be connected directly to the directional control valve. So how do I make this cylinder extend? And likewise, how do I make this cylinder extend? The control method is the same. As you can see, to make this cylinder extend, okay, all I need to do is to energize one SOL and the valve will be switching to this position. Okay, the same goes for this circuit over here. When I energize one SOL, the valve will be switching to this position and hence the cylinder will extend. You can look at the simulation circuit later on to see how the valve can switch around. For now, I will just label what's the purpose of one SOL, which is to make the cylinder extend. Okay, to make the cylinder extend, I call the cylinder A, okay, and plus means extend. Okay, how do I make the cylinder retract? So to make the cylinder retract, all I need to do is to energize 2 SOL so that the valve will be at this position, and you can visualize that the cylinder will retract. So the 2 SOL is to make cylinder retract. Same goes for this. When you energize 2 SOL, the valve will be at this position and you can see the air going to the rod side to make the cylinder retract. So now, I want to do a control such that when I press 1 PB, the cylinder will extend. It will retract when 2 PB is pressed. So I write down the purpose here. When I press 1 PB, I want to make the cylinder extend. Again, A stands for the cylinder. I give it a name called A. Plus means extend. When I press 2 PB, the cylinder A will retract. Okay, so take a look at this direct control circuit over here. You can see that to make A extend, all I need to do is to press 1 PB and connect to a 1 SOL to make A extend. Okay, again, to make A retract, all I need to do is to have the 2 PB over here and tie it to 2 SOL. Okay, so that when you press 2 PB, 2 SOL will be energized and cylinder will retract. So this is called direct control because it doesn't have any signal processing element. In other words, it has no brains in the system, which is not the preferred way we are going to have, because in real life application, the circuit will be more complex. So from now onwards, we will focus on indirect control. Okay, let's take a look at solution 2. indirect control, whereby we have signal processing elements such as the control relay. So we are having brains in the system to control the solenoids. So as you can see, the purpose of 1CR obviously is to make A extend. Because when you want to press 1PB, you want the cylinder to extend. And the purpose of 2CR is to make A retract. Okay, as you can see over here. So when 1CR is being energized, when 1PB is pressed, the contact here will close and the cylinder will extend because 1SOL is being energized. When 2PB is pressed, 2CR will be energized, the contact will change, will close, and the solenoid will be energized, the cylinder will then retract. So this is how we do indirect control. We will now take a look at the circuit diagrams and you can visualize how this circuit will work for indirect control. Now I will take a look at this simulation circuit 2-directional control, whereby I'm using a 5-2-way double solenoid directional control valve. And double solenoid directional control have pneumatic memory, which we learned earlier, which means that it remembers its last position. Just to recap, when you energize 2SOL, it will be at this box for the directional control valve. When you energize 1SOL, the directional control valve will switch to this box. Okay, so as you can see, when you energize 2SOL, cylinder will retract. Okay, as you can follow the air flow here, you will enter the rod side. When you energize 1SOL, the cylinder will extend because it will switch to this box. So let's visualize what we meant by remember its last position. Okay, so when I press 1PB, 1CR will turn on, the contact will close, 1SOL will be energized. Okay, so I'm only going to press 1PB momentarily. Okay, that means I press and let go. Let's observe. I press 1PB and I let go. Okay, the directional control valve is still at this box. The cylinder is extending and it will stay extended because the directional control valve is at this check box as I've energized 1SOL just now. Okay, so how do I make the cylinder retract? All I need to do is to press 2PB momentarily. 2CR will turn on, contact will close, 2SOL will be energized. Directional control valve will switch to this box and the cylinder will retract. Okay, so let's take a look. I press 2PB momentarily and I let go. No more power to 2CR. 2SOL has no more power, but because it has pneumatic memory, it remembers this position. Okay, as just now I have energized 2SOL, hence the cylinder is now retracting and it will stay retracted because of the position of this directional control valve. So in this circuit, you should be able to understand that double solenoid directional control valve have pneumatic memory, which means that it remembers its last position. It just needs to be energized for a short while only for the solenoids, okay, in order to make it extend or retract. Now we are back to the worksheet and I will take a look at the next circuit, automatic return. So when 1PB is pressed, the cylinder will extend. Upon reaching its fully extended position, it will retract automatically. So you can see that this pneumatic drive circuit has this 1LS over here. The purpose is to detect that it has reached its fully extended position. So let's write down the flow of this question. When you press 1PB, cylinder will extend. Okay, I write A plus, cylinder A will extend. Upon reaching its fully extended position, which is 1LS, the cylinder will then retract automatically. Okay, so let's take a look at this electrical ladder diagram and we will first write down the purpose of each control relay. So as you can see, 1CR, the contact is being connected to 1SOL, and from this pneumatic drive circuit, I can see that 1SOL will make cylinder extend because the valve position will be here. Okay, and 2SOL will make cylinder retract because the valve position will be here and you can trace the air supply. Okay, and the air, you can notice, is reaching the rod side of the cylinder, so the cylinder will retract when 2SOL is being energized. So I can safely write here that 1CR is to make A extend because you're energizing 1SOL, and 2CR is to make A retract because you're energizing 2SOL. So looking at this control circuit over here, okay, I can understand that when you press 1 PB, A will extend, which is already been achieved in this circuit. Okay. However, this part here, when 1LS is activated, cylinder will retract. Okay, so I know that 2CR is controlling the retraction. So over here, I know the answer will be 1LS. However, 1LS, look at the circuit over here. Is it activated? No, it's not. So there are two possible answers to 1LS, because in the non-activated position, okay, 1LS can be normally open or normally closed. Okay, I will first write the normally open and then I will analyze. Okay, so I will draw 1LS normally open first and I will start to analyze. When you press 1 PB, 1 CR will be energized, the contact will close, cylinder will start to extend. So it will slowly extend. Once it reaches 1 LS, it will be activated. So when you draw normally open, it will become normally open held close, and 2 CR will be energized, the contact will close, and the cylinder will retract. So this is the correct answer. You can try on your own by inserting a normally closed limit switch to understand why it is not possible for this solution. Okay, so let's take a look at the simulation circuit now.
So now we are looking at this simulation circuit for automatic return, whereby we are using a 5-2-way double solenoid directional control valve, and we are also using a limit switch to detect whether the cylinder has reached its fully extended position. Okay, so let's take a look at this control circuit. So what this circuit does is when I press 1 PB, I will energize 1 SOL. Okay, so the cylinder will then start to extend. Once it's fully extended, the limit switch will become closed, normally open held closed, and the cylinder will then automatically retract back to its original position. Okay, so let's take a look at the first observation, whereby I'm going to press 1 PB momentarily to energize 1 SOL. So you can see that when I press 1 PB momentarily, 1 SOL is energized, and I let go of 1 PB. The directional control valve is at this position, the cylinder is extending, and then once it reaches its fully extended position, we will touch 1LS. 1LS will become normally open held closed. As you can see, 2 solenoids energized. The cylinder will then start to retract because the directional control valve is at this position, and it stays at this position because this is double solenoid. You remember its last position. So you can see the cylinder starts to retract, okay, and it will stay retracted. Okay, let's look at this circuit again. I press 1 PB, energize 1 SOL, and the valve will be at this position, cylinder will extend, okay, and then once it is fully extended, we will make 1LS normally open held closed, energizing 2 CR, okay, as you can see, and 2 SOL will be energized. Directional control valve will be at this position, the cylinder will then retract, okay, and because the piston is no longer touching 1LS, it will go back to normally open position, which is its default position. So this is how this automatic return circuit works, okay, with the help of 1LS.
Now we are back to the worksheet and we will look at the next page, time delay control. So when a 1 PB is pressed, the cylinder will extend and dwell for a few seconds at the fully extended position at 2LS before retracting automatically. Okay, first you must understand the meaning of dwell. Okay, dwell means stay. Okay, stay there for a few seconds. Okay, so let's write down the flow of this circuit. Okay, so when you press 1 PB, cylinder will extend A plus. Okay, and it will stay there for how long? A few seconds. Since the question did not say, I will just write 3 seconds here. So how do you know that it is at its fully extended position? Because they have a limit switch here, 2LS. I know that it has reached 2LS first, and then it will stay there 3 seconds. After that, it will retract automatically. Okay, so this is how this circuit is going to work. When you press 1 PB, A will extend. It will reach 2LS because it knows that it has already been at the fully extended position. After that, it will be at the fully extended position for 3 seconds before it retracts. Okay, so I know I definitely need a timer. Okay, so let's draw the timer here. I will definitely need a timer relay coil and timer contact. Okay, either draw normally open or normally close. Okay, and then we shall see which one is the correct answer. Okay, so let's take a look at this diagram now. So you can see that there are two limit switch, 1LS and 2LS. Okay, 1LS is in its activated position because the piston rod is touching, and 2LS is not activated, so it's either normally open or normally closed. In this case, you can see they draw normally open. Okay, so let's analyze first. First, before we do the thing, we always like to write down what is the purpose of the control relay. So can you tell me what's the purpose of 1CR? Okay, take a look at the contact of 1CR. It's used to energize one solenoid. Okay, so I know one solenoid is used to make the cylinder extend. Okay, so 1CR is to make cylinder A extend. Okay, and when do you want the cylinder to retract? Okay, 2SOL is to make cylinder retract, right? So when do you want to make the cylinder retract? Okay, let's look at this flow here. 3 seconds later, then I want to make the cylinder retract. So you can see this 3 seconds later. Okay, the cylinder will then retract. So what should I draw here? I should draw the contact of the timer relay, because only the contact of the timer relay is able to switch accordingly, okay, to the timing. So I will draw a normally open 1TR. Okay, why? Because 3 seconds later, this normally open 1TR will then close to make the cylinder retract. Okay, now let's take a look at this. Second limit switch, what is it supposed to turn on? Okay, since you draw the timer relay contact, you need to draw the coil, correct? So you read the question again. It says that when the cylinder piston is at its fully extended position, then you start your timer, right? Then 3 seconds later, it will retract. So who will start this timer coil? Okay, it will be the second limit switch. Okay, so over here, I'll write here 1TR. Okay, and it is very important to write the 3 seconds here. Okay, so for every timer coil, you need to write the preset time, which I already said it to be 3 seconds. Okay, let's visualize this again. So you can see that when you press 1 PB, current will flow from left to right, okay, to energize this control relay coil, and the cylinder will extend because the contact will close. It will change to close, and the cylinder will extend because solenoid 1 is being energized. So cylinder will slowly extend until it reach 2LS. Okay, when it reach 2LS, normally open will become normally open held close, and it will energize this timer relay. Okay, so when this timer relay is being energized, 3 seconds later, this contact will close. Okay, this timer contact will close, and it will energize this second solenoid to make the cylinder retract. So this is exactly what we want to achieve over here. And with this, let's take a look at the simulation circuit to understand better. Okay,
now we're looking at the simulation circuit for time delay control. Okay, basically what this circuit does is the cylinder will stay at this 2LS for a period of 3 seconds. Okay, then it will start to retract back. So again, let's take a look at the simulation circuit. Okay, whereby I'm going to press 1 PB. You will see that the solenoid will be energized. Okay, because the control relay coil is energized, the contact will close, the solenoid will energize, and hence it will be at this box of the directional control valve, and the cylinder will start to extend. One is fully extended at 2LS. You can see that the cylinder will not immediately retract back. Instead, it will stay at this 2LS position for a period of 3 seconds. After that, this normally open will become normally open held close, and 2SOL will be energized to make the directional control valve at this position, and the cylinder will then retract. Okay, so let's take a look. When I press 1 PB, 1CR is energized. Okay, 1SOL is energized momentarily, cylinder is extending. Okay, and once it reaches 2LS, it will become normally open held close. As you can see over here, the timer relay will be energized. The contact will be switched on 3 seconds later. Okay, so 3 seconds up, solenoid is energized, the valve is at this position, cylinder will start to retract back, okay, and when it retracts back, you can see 2LS will fall back to normally open position because it's no longer touching the piston rod, and hence timer will not be energized, timer contact will be open, okay, and solenoid is not energized, but because it's double solenoid, you remember its last position, it will be at this position until the cylinder is fully retracted, okay, and it will stay retracted. So let's watch again. When I press 1 PB, okay, momentarily, 1 SOL is energized for a short while. It will stay at this position. Cylinder will extend, and once it's fully extended, it will touch 2LS, become normally open, held close. Timer relay coil is now being energized. 3 seconds later, observe this. Contact will close. Solenoid will be energized. Okay, directional control valve at this spot. Cylinder will start to retract. Once it leaves that position, okay, normally open again. Timer relay coil is off. Timer relay contact is open again. Solenoid is off. But because it remembers its last position, the cylinder will start to retract and it will stay retracted. So this is the time delay control using a double solenoid directional control valve and with the help of the limit switch.
We are again back to the worksheet, and we will take a look at the next circuit with automatic return with initial position. Okay, so let's take a look at this question. The cylinder will extend to its fully extended position when two conditions. The cylinder piston is at its retracted position and a push button is pressed. When the cylinder reaches the fully extended position, it will retract automatically. Okay, so as you can see, there are two limit switch here, 1LS and 2LS. 1LS is already activated, okay, so it detects retracted position, and 2LS is non-activated, okay. So let's write the flow of this circuit first. When 1 PB is pressed and the cylinder piston is at its fully retracted position, okay, how do you know it's fully retracted? I know it's 1LS, okay, because the cylinder has no eyes. It's relying on the limit switch to detect whether is it retracted or extended. So when 1 PB and the cylinder piston is at its fully retracted position, okay, the cylinder will then extend, okay, the cylinder will extend to its fully extended position. How do you know it's fully extended? Okay, you will reach 2LS, okay, and the question says when the cylinder reaches the fully extended position, it will retract automatically. So when it's reached a fully extended position, it will then retract. Okay, so this is the flow of this circuit. So let's see how we are going to solve this. I'll label plus minus first, and I will also label what's the purpose of 1CR. So as you can see, what's the purpose of 1CR over here? The purpose of 1CR, as you can see from the contact, is to make cylinder extend because it's energizing solenoid 1. So I'll write here A plus. Okay, and what is the purpose of 2CR? The purpose of 2CR, as you can see from the contact, is going to make cylinder retract. Okay, so 2CR is to make cylinder retract. Okay, so let's take a look at the question first. 1 PB and 1 LS will make cylinder extend. So 1 PB and 1 LS will make the cylinder extend. Because you extend, you are energizing 1 CR. So I should fill in 1 LS over here. So what should I fill in? Okay, 1 LS is activated. Okay, so 1 LS can be normally open, held close, or normally close, held open, because it's at activated position. Okay, so which one should I draw? Okay, activated means that the piston rod is actually touching the limit switch initially, okay, as you can see from this circuit diagram over here. 1LS is activated right at the start. So what should I draw? Okay, let's try and draw normally close, held open, okay, and then let's visualize. So as you can see, if 1LS initially is normally closed, held open, do you think 1CR will ever turn on? No, it will never turn on. Even though if you have pressed 1 PB to make it close, 1LS is at normally closed, held open position, it will never energize 1 CR, and hence your cylinder will never extend, which is not what the question wants. So this is wrong. So let's draw normally open, held, close instead. Okay, so now I'm drawing a normally open, held, close for the limit switch, and let's visualize. When you press 1 PB, it will be closed, current will flow from left to right, and because 1 LS is normally open, held, close, it will also allow current to flow through and energize 1 CR to make cylinder extend. So this is correct. 1 PB and 1 LS will make cylinder extend. So who will make cylinder retract? Okay, as you can see from this control chain here, 2 LS will make cylinder retract. Okay, so 2 LS will make this 2 CR turn on, and hence cylinder will retract because this contact will change, it will close, and cylinder will retract. So the answer here will be 2 LS. 2 LS is not in an activated position. Okay, so over here 2 LS is not activated, so it can either be normally open or normally closed. Okay, because it's not activated, as you can see from the pneumatic drive circuit. Okay, 2RS is not activated at the start, so it's either normally open or normally closed. Which one should we draw? Okay, I will draw normally open. Okay, the reason is because, take a look at the circuit diagram again. 2RS is not energizing 2CR until you have activated it. Okay, so when you press 1 PB and your cylinder is at 1 LS position, which is normally open, held, close, it will energize 1 CR and make the cylinder extend. So the cylinder will slowly extend. The moment it touches 2 LS, normally open will become normally open, held, close, and hence you will energize 2 CR. When 2 CR is being energized, the contact will change, it will close, and the cylinder will retract, which is exactly what your control chain is illustrating. Okay, so I repeat again. 1 PB and 1 LS will make cylinder extend, which is what we have drawn here. 1 PB and 1 LS will make cylinder extend because 1 CR is making cylinder extend. 2 LS will make cylinder retract. So 2 LS, because it's energizing 2 CR when it's being activated, because when it's activated it becomes normally open, held, close. It will activate this 2 CR and then it will make cylinder retract. Okay, which is what we want. So let's take a look at the simulation circuit again, and you can visualize. Now we take a look at this simulation circuit for single cycle mode. This time round we will have two limit switch, 1LS and 2LS, and we are still using a double solenoid directional control valve, which means that it has pneumatic memory. You remember its last position. So as you can see from this cylinder position that 1LS is now activated because it's at retracted position. Hence, look at the circuit, it's drawn as activated, which is normally open, held, close. Okay, and 2LS is not activated and we have drawn it normally open. Okay, so let's take a look at this circuit. When I press 1 PB, you will realize that 1 CR will be energized. Okay, and the contact here will close and the solenoid will be energized. Directional control valve will be at this position, the cylinder will extend. Okay, let's press this. So you can observe that 1 CR has been momentarily energized. The cylinder piston will start to extend. And you can see that 2RS will be activated, 2CR will be energized, 2SOL will be energized, and the cylinder will then retract. Okay. At this point of time, you notice that 1LS and 2LS is both at normally open position. Why? Because none of the limit switch is activated. Okay. However, when the cylinder is at its retracted position, which is going to reach very soon, you will notice that this one will become normally open, held, close, because 1LS is now activated as the cylinder piston is now retracted. Okay, let's observe this again. Okay, press 1 PB, 1 SOL, energize momentarily, cylinder will extend. Okay, and once it reaches 2 LS, 2 SOL will be energized momentarily and cylinder will retract. And when the cylinder starts to retract, you will leave 2 LS, 2 LS will open back again. And you can see at this point of time,
both the limit switch is at normally open position because the cylinder piston is at the center. And once it's fully retracted, okay, you can notice that limit switch 1 will be normally open, held closed because it's now activated. Okay, so this is how we use limit switch to detect whether is it retracted or whether is it extended. Okay.
Now we are at the worksheet and we will look at continuous cycle. How are we going to achieve using a toggle switch? And as you know, a toggle switch is different from a push button. When you close the toggle switch, it will stay closed until you press again, then it will open. So in this scenario, I want to close the toggle switch and the cylinder will extend and retract continuously. The automatic mode will halt when 1TS is open. So let's write down the flow of this question first. So when I press 1TS and the cylinder is at its retracted position, okay, which is at 1LS, okay, the cylinder will then extend. Once it reaches fully extended position at 2LS, the cylinder will then retract. Okay, how do you know it's fully retracted position? You must be able to reach 1LS again, and then this cycle will continue. So let's take a look at the two limit switch here. 1LS is to detect retracted position, 2LS is to detect extended position. So you can see 1LS is already been activated. So they draw normally open, held closed because it's already been activated by the piston. Okay, and 2LS, they draw non-activated. In this case, they draw normally open. So let's first analyze what's the purpose of each control relay. As we can see, 2SOL will make cylinder retract because the valve position will be here and the cylinder will be retracted because the air is entering from the rod side. So let's label first. So 1SOL is to make A extend. So let's take a look at this control circuit. 1CR is here, okay, and the purpose of 1CR is to make 1SOL, okay, energize. So 1SOL is making A extend, so I will write the purpose of 1CR is to make A extend, and 2CR is to make A retract because you can see the contact of 2CR is being connected to 2SOL, which will make A retract. So we already write down the purpose of each control relay. What should we fill in here? Okay, well, as we can see from this control chain, the obvious answer will be the toggle switch because let's draw the toggle switch now. Okay, and I will label it. When I close this toggle switch, and because this limit switch already been normally open, held closed, control relay will be energized, the cylinder will extend. Once it's at its fully extended position, the cylinder will energize 2CR and the second solenoid will then be energized, the cylinder will then retract. And this circuit will go on and on because 1TS is closed. When you open 1TS, then the circuit will stop. So now, let's take a look at the simulation circuit. Now we shall take a look at this simulation circuit where we will achieve continuous cycle using a toggle switch. Okay, and the toggle switch is different from push button. Toggle switch, when you press, it will stay closed, okay? And then when you press again, then it will open the toggle switch. So in this case, the moment I press the toggle switch, it will stay closed. And then I have to press again, then it become open. Okay? Continuous cycle can be achieved also because of these two limit switches here. Because with the help of the limit switch, I'm able to know the retracted position of the cylinder and the extended position of the cylinder. We are also using a 5-2-way double solenoid directional control valve, which means that the solenoid just need to be energized momentarily as it remember its last position. So, as you can see over here, the cylinder piston now is at retracted position, means that 1LS is now activated. Hence, you can see that it is normally open, held closed. By closing this toggle switch, which I'm going to do that in the next moment, you can see that 1CR will be energized because the current can flow through. And the contact will close, the solenoid will be energized, the directional control valve will be at this position, and the cylinder will extend. Okay, so let's close this toggle switch. You can see that 1CR is energized, 1SOL is on, directional control valve is at this position, cylinder will start to extend. The moment it is fully extended, look at 2LS, it will become normally open, held closed. It's activated, 2CR is energized,
2SOL is energized. Directional control valve is at this position, the cylinder will start to retract. The moment it's retracting, you can see that piston is no longer at extended nor retracted position. Both limit switch is actually open. Okay. However, the moment the cylinder piston reaches retracted position, you can see over here, it becomes normally open, held close again. You will energize one CR, one SOL will be energized, and the cylinder piston will start to extend again. Once it reaches its fully extended position at 2LS, 2SOL will be energized, cylinder will start to retract. Okay. And you can see this cycle will go on and on again. Okay, so how do I stop this continuous cycle? Okay, if you visualize this toggle switch, all we need to do is to open it, and then the cylinder will then complete its retracting motion, and it will just stop there. Okay, so let me see. Now I'm going to just open this toggle switch. No more power going to one CR. The cylinder will never extend again because one CR will be off as one TS is now open, even though your limit switch will be at normally open, held closed position, as you can see. Okay, and the cylinder will just stay retracted. So you can actually control using a toggle switch to achieve continuous cycle. So now let's go back to the worksheet.
So we are now back at the worksheet, and previously we looked at continuous cycle using hard memory, which is toggle switch. Now we are going to look at continuous cycle using soft memory, which is push button. Again, I want to emphasize that there's a big difference between a toggle switch and a push button. For a toggle switch, if your toggle switch is normally open, when you press, it will become closed and it will stay closed. However, if you are talking about push button, and if you are talking about normally open push button, if you press, it will become normally open, held closed. However, when you let go of your finger at the push button, it will become normally open again. So it will go back to its original position. Hence, you cannot directly replace a push button with a toggle switch here. Okay, so how do we make sure that this cycle will keep on extending and retracting? Okay, that means one CR will always be on, and then when it reaches 2LS, 2CR will be on, and the cylinder will extend and retract. Okay, we know that 1 CR is to make A extend and 2 CR is to make A retract, which is cylinder A retract. So how are we going to achieve that? Okay, first thing, I know I need to have something to replace the toggle switch. The toggle switch used to be here, right? So the moment the toggle switch is closed, the cylinder will then extend. After that, when it reaches fully extended position, the cylinder will retract, and so on and so forth. So instead of a toggle switch, I will use a control relay. Okay, I call it ACR. Okay, so I create the contact of the ACR to replace the toggle switch. I need to create the coil of the ACR. Okay, A stands for automatic. Okay, so I cannot use the name 1CR because 1CR coil is already been used. I cannot use 2CR because it's already been used. I can use 3CR. Okay, it's just a name. So for me, I call it ACR because I want to represent automatic cycle. So I'll call it auto cycle. So when ACR is energized, this contact will close, ACR contact will close, and cylinder will extend because 1CR is closed, this thing will close, cylinder will extend. Okay, and when the cylinder is fully extended, 2LS will activate 2CR and the cylinder will retract. Okay, and the cycle will keep on continuing because ACR is constantly closed by this control relay. Okay, so who control this ACR? So now I'm going to draw, okay, the template, okay, which is what I teach you earlier, start, stop, latch. Okay, so I draw the latch first, which is easier. So ask yourself, who will start this automatic cycle? The question will tell you 1 PB. So I will draw a normally open 1 PB. So can you imagine that when I press 1 PB, ACR will turn on, the contact will close, and the cylinder will extend? Okay, so when do you want to turn off this ACR? Okay, when your 2 PB is activated. Okay, so let me draw this 2 PB over here. I will draw normally close. Okay, the reason is because when you draw normally close, when you press it, it will become normally close, held open. Okay, so the circuit will break and no more power going to the control relay. It will stay open and your cylinder will not extend anymore. So that's how we design continuous cycle using 2 push button and of course with the help of a control relay and its latching circuit. Okay, so let's take a look at the simulation circuit one more time and you can visualize how it works. Now we will take a look at this simulation circuit where we will achieve continuous cycle using 2 push button and 1 control relay. As you can see, we also have 2 limit switcher to detect retracted and extended position, and using a 5 two-way normally open double solenoid directional control valve, which means that it will remember its last position. It just needs to be energized momentarily. Okay, so let's take a look at this circuit. When I press 1 PB, ACR will be energized. Okay, the contact will close and it will stay closed. Okay, and the cylinder will extend. When it's fully extended, you can see that normally open will become normally open held close. 2CR will be energized, the contact will close. Okay, 2SOL will be energized. The valve will be at this position, the cylinder will start to retract. Okay, so you can see that 1 ACR is still on. Okay, because of this latch. So now, when it's at retracted position, you will see that this 1LS will become normally open held close. And 1CR will be energized, solenoid will be energized, 1SOL, and the valve will be at this position to make the cylinder extend. Okay, and when it's fully extended, 2LS will be activated. Okay, 2SOL will be energized, cylinder will start to retract. Okay, so you can see this cycle going on and on. Okay, and the only way to off it is to off ACR, which I'm going to do that now by pressing 2 PB. I turn off ACR, and even if the cylinder piston is at retracted position, normally open held close, because ACR is now off, there will be no power going to 1CR coil. Okay, hence the solenoid 1 will never be energized, so the cylinder will stay at its retracted position. So this is how I stop the cycle. So let's try again. When I press 1 PB, 1 ACR is energized, 1 LS is at normally open held close, and the moment the piston starts to leave, okay, you can see it opens up. Okay, so none of the solenoid is energized, but for now, look, 2LS will be normally open held close, 2SOL will be energized, cylinder will start to retract. So you can see that no solenoid is being energized when the cylinder is actually retracting. Okay, because this is a 5 two-way double solenoid directional control valve, you just need to energize the solenoid momentarily. Okay, so you can see the cycle just keep on repeating, going on and on, as long as my ACR coil is being energized. Okay, so now I'm going to stop this cycle by pressing 2 PB. So when I press 2 PB, ACR will be off. Okay, so even though later on the cylinder retracts back to retracted position, 1LS is normally open held close, 1CR will still be off. Okay, as you can see. So the cycle has stopped. Now we will go back to the worksheet. Now we are back to the worksheet and we will look at this circuit over here, whereby we will still achieve continuous cycle but with the cylinder initially extended. So let's take a look at this pneumatic drive circuit and understand why the cylinder now is initially extended. As you can see over here, this circuit comparing with this circuit, the pneumatic tubing has been swapped. Okay, so let's visualize this. If you energize 2SOL over here, you can see that the valve control will be at this position. The air will go through to the ball side to make the cylinder extend. So I will say that 2SOL will make A extend. Okay, and 1SOL will energize the valve to be at this position, and hence cylinder A will retract. I will also label the limit switch here, 1LS, 2LS, like the diagram above. Okay, So now I will apply the same control circuit technique to achieve continuous cycle by having two push button and a control relay. Okay, so let me draw the push button first. Okay, and then the latching circuit. Okay, I call the continuous relay ACR. It's just a control relay. And you can see that 1 PB will start the continuous cycle and 2 PB will stop the continuous cycle. Okay. Now, I need to label the limit switch. Okay, but before I do that, I think it's good to understand what's the purpose of 1CR first. So as you can see, 1CR will energize 1 SOL because the contact of 1CR is being connected to 1 SOL, and 1 SOL will make A retract. Okay, same for 2CR, the contact is being connected to 2 SOL and it will make A extend. So the purpose of 2CR is to make A extend. Now, you may want to draw the flow of this question to help you to fill in what's this limit switch here and what is this limit switch over here. So, let's draw. When you press 1 PB, okay, and the cylinder is initially extended, so it's 2 LS, cylinder will retract. Okay, when you press 1 PB, okay, ACR will turn on, cylinder will retract because you will energize 1 CR. Okay, so cylinder will retract. When it is at its retracted position at 1 LS, it will then extend. And how do you know it's fully extended? You will go back to reach 2 LS and the cycle will continue until you press 2 PB to switch off the ACR. So from this, you can see that the ACR and 2 LS will make cylinder retract. So ACR and 2 LS. Okay, and you can also see that 1 LS will make cylinder extend. Okay, so 2 CR is going to make cylinder extend. So 1 LS will be here. Turn on 2 CR and cylinder will extend. Other than drawing this control here, you can also find out the answer by looking at the limit switch over here. You can see that 2LS is at activated position, and they already draw activated position here, normally open, held, close, and 1LS is at non-activated position. That's why they draw normally open, so that when it is activated, it will close and make your cylinder extend. So now we will take a look at the simulation circuit to understand better. Now we will take a look at this continuous cycle whereby you will see this cylinder initially extended. How do we achieve that? First, take a look at this directional control valve. Okay, the default position of the directional control valve is always on the right. Okay, so as you can see, the air now is going to the ball side of the cylinder to make the cylinder extend. Hence, we have actually crisscrossed the tubing as compared to the previous circuit so that the air is going to the ball side of the cylinder. Okay, so now when I press 1 PB, you can see that 1 ACR will be energized, the contact will close, and because the cylinder is now initially extended, that's why 2LS is normally open, held, close. 1 SOL will then be energized because 1 CR coil will be energized, contact will close, 1 SOL will be energized, the cylinder will then start to retract. Okay, and then you will notice that to make it extend back again, all I need to do is to energize 2 SOL. So let's visualize this circuit step by step. When I press 1 PB, ACR will be energized. Okay, the contact will close, 1 CR will be energized, 1 SOL will be energized momentarily. You can see the valve is switched to this position. The cylinder is now retracting. Okay, and when it's fully retracted, 1 LS will become normally open, held, close. 2 CR will be energized, and then 2 SOL will be energized. Okay, you can see over here. Okay, it's at this box, and the cylinder starts to extend. Okay, and you can see that when 1 SOL is being energized, the cylinder will just retract. Okay, so how do we stop this cycle? All we need to do is to make sure ACR is off. Okay, I need to make this contact goes back to normally open position. Okay, so how do I do that? I need to de-energize this control relay 1 ACR. So I will press 1 PB to break the circuit. Okay, and ACR is now off. Even though 2LS is normally open, held close, the solenoid will not be energized. The cylinder will stay initially extended. Okay. The last example of today's video, which is automatic cycle with proximity sensor. Okay. So a proximity sensor is used to monitor continuously the presence or arrival of workpieces. In the automatic mode, the cycle will be executed whenever a workpiece is detected. So this is the proximity sensor. PS stands for proximity sensor. Okay, and you can see that this is the cylinder. So let's take a look at the pneumatic drive circuit. So this is the pneumatic drive circuit, okay, whereby you can analyze that the air supply of the directional control valve and the tubing is being wired to the rod side of the cylinder. Okay, so you can see that this check box, right, it actually belongs to second solenoid because it's closest to it. So when it is at this check box, okay, the cylinder will retract because the air is going in from the rod side. So I will first label. Okay, next I will take a look at the limit switch here. So I can see that this 1LS is a activated position. So activated means it can be normally open, held closed, or normally closed, held open. And this second limit switch is a non-activated position. That's why it's either normally open or normally closed, depending on how you draw in your circuit diagram. So let's take a look at this circuit diagram now. I can see that they're using ACR control relay and the contact is here. So obviously this control relay ACR means automatic continuous cycle. They are using it as a continuous cycle, so I call it auto cycle. Okay, so when you press start push button, it will close and ACR will turn on and it will close this contact. Okay, so they also write down 1CR here, and the purpose of 1CR is to energize. When it's energized, the contact will close and it will make solenoid 1 turn on. So what is solenoid 1? From this pneumatic drive circuit, solenoid 1 is to make AA extend. So I'll label this first. So I can safely say that when you energize 1CR, the purpose is to make cylinder extend. Okay, because as you can see, the control relay coil is here, the contact of this 1CR is here. So when 1CR coil is being energized, the contact will close and the cylinder will extend. So the same goes for the 2CR. Okay, 2CR, because it's controlling 2SOL, which is going to make cylinder retract. So the purpose of 2CR is to make cylinder retract. Okay, so let's write down the flow of this question first. Okay, so can I say that when auto cycle is on, okay, so when you press the start button, okay, and 1LS cylinder is initially retracted, okay, and sensor should be on. Okay, I will write here over here. Okay, let me pull out the eraser. Okay, so maybe I use the plus sign, easier. And plus sensor on, 1 PS on. Okay, then the cylinder will extend. Okay, then how do I know it's fully extended? It will reach 2LS. Okay, so when it reaches 2LS, then the cylinder will retract. Correct? And then the cycle will goes on. Okay, provided that the sensor turns on again. So as you can see over here at the control circuit, okay, the start is actually represented by 1 ACR here, because when you press start, ACR will turn on. Okay, and you'll turn on forever until you press stop. So let's imagine that we turn on start. We press the start button, ACR turns on, this contact will close, and limit switch is normally open, held closed so that the current can flow through, and it's at activated position as you can see. So what should we fill in for here? It should be the sensor. And do you still remember how to draw sensor? Okay, you have learned in EP3 earlier that sensor, we are normally using a 3-wire sensor, so the plus is always on the left. minus, okay, connect to the minus, and the signal will connect to the control relay. So I will also label this sensor here 1PS. So can you imagine when the sensor is on, okay, current will flow through and you energize the control relay. So when you energize 1CR, the contact here will close and the solenoid will be energized and the cylinder will then extend. Okay, then this control circuit will go on and on until someone press stop push button. It will disconnect the ACR current, okay, and hence ACR will become open and the cylinder will not move anymore. So to visualize this better, it's always good to look at the simulation circuit first. So let's take a look at the simulation circuit. Now we are going to look at the simulation circuit whereby we will achieve automatic cycle with a proximity sensor. Again, we also have the two limit switch here to detect retracted and extended position. We again have two push buttons here to do the continuous cycle mode. So when I press 1 PB, okay, you can see that ACR will turn on, okay. 1 LS is at normally open held closed position because the cylinder is now retracted, okay. So I will use this to simulate the workpiece sensor. When I press this, it means that the sensor senses that there's a workpiece there, okay. So when the sensor senses that there's a workpiece there, 1CR will turn on and the solenoid will be energized, okay, and the cylinder will extend. So let's look at this. When the sensor senses the workpiece, you can see that 1SOL is on and the cylinder starts to extend, okay. And one is fully extended, it will reach 2LS. Normally open, held, close here. Second solenoid will be energized, the cylinder will then start to retract, okay. So you can see my ACR is still on, okay, because just now I pressed the push button and the latching circuit will help to power up the control relay here. So you can see that the cycle will stop here. Why? It's because I'm still waiting for the workpiece to come. Okay, so imagine that I sense that the workpiece is here. Okay. 1CR will turn on again, solenoid will be energized, the cylinder will extend. Okay, so you can see that I can achieve automatic cycle with this proximity sensor. And you can observe the cylinder will then start to retract. And once it's retracted, 1LS will become normally open, held, close, okay? Just waiting for the workpiece to come. So the sensor senses the workpiece is here. Okay, 1CR will be energized. Cylinder will then extend again because 1SOL is on. Okay, so this circuit will just goes on and on and on, waiting for the workpiece to come, and then the cylinder will then extend and retract. Okay, as you can see earlier. So now, to break this cycle, all I need to do is to turn off ACR. Okay, so once ACR is de-energized, the contact will go back to open. Okay, and I'm going to break the circuit over here. You can see ACR is now open. And the cylinder will not extend again, okay, because ACR contact is now normally open. No current will flow through, okay, even if your sensor senses an object. Okay, so this is how you achieve automatic cycle with proximity sensor.